Okay.
My goodness, look at all these lovely humans. All right, guys, we're gonna wait like about probably like a little bit longer, about like 30 seconds probably, or to a minute to see if anyone else is gonna join. And then I'm gonna go through what today's meeting is focused on. And then at the end, if we have any questions with anything, we can definitely talk that through as well. Okay? So we're gonna wait about 30 more seconds. Things that you need for this meeting. You do need your iPad or Canvas page, or you can do this on a sheet of paper if you would prefer. So you can do it on your iPad. There is the list of sources on your Canvas page, which I'm going to show right now. So the first thing with that is yesterday there was a formative, okay, and it was put into the grade book. If you did not get a chance to take it, I will still grade it. Make sure that you get a chance to take it because that's my ability to give you some feedback about net ionic equations. All right. Overall, they were pretty good. There will be a video of me breaking that down coming out probably tomorrow. I want to wait just a little bit because I still have quite a few people who have not had a chance to take it yet. Okay. So any questions with that as of right now?
I have a question.
Yes, Ms. Fatima, what's up?
So like, cause sometimes I can't hear you because other people are making too much noise. So can you mute them while you're talking, and then like,
yes,
if someone has a question, they unmute.
Yeah, I think there should be a way that you guys can raise your hands.
Yeah, if you press on the three dots.
If you press on the three dots, okay, so we'll use that version then. So I'll mute you guys when I'm talking, and then if you have questions with it, press the three dots, or you can also, if you put it in the chat, it'll like pop up for me and it should pop up for everyone else. So I'm gonna mute you, and then if you have a question, either raise your hand or put it into the chat, and I'll unmute you at the end if we have any overall questions.
Hi, Miss Edge.
Hi guys, I hope you're all doing well. Welcome to virtual classroom today. Okay, so first things first, kind of breaking down what is happening. So on the Canvas page, how I set up this week is you had your formative yesterday. And again, you can take that if you need it still, okay? And then today, you're currently in the meeting, so you'll be responsible for doing the Edpuzzle tomorrow, okay? The meeting and the Edpuzzle go together. It doesn't matter if you did the, oh goodness. It doesn't matter if you did the Edpuzzle today and then they'll attend the meeting tomorrow, or either way, it will work out well, okay? So the purpose of today's meeting is we are focusing on our new content, which is going to be the equilibrium constant calculations, okay? So if you have a separate calculator, that would also be handy for you because we are gonna do some math, okay? Your phone or your iPad will work, but if you're like me, I like the calculator of it, okay? So the first one that you're gonna click on in today's content is the equilibrium constant calculations, okay? So, should pull up like this. Okay, so we had the chance to talk about equilibrium in your vocab terms, okay? So equilibrium is this specific type of reaction in order of that can be reversible, all right? And the difference, how you will know that it's an equilibrium reaction, okay, is it has this forward and reverse arrow. One second, guys, sorry. Okay, it has this forward and reverse arrow. That means that it can go back and forth, okay? It means that the rate of reaction going forward is equal to the rate of reaction going opposite, okay? So within an equilibrium reaction, all right, there are a couple things that we need to know, all right? We are looking to calculate the K. K is the equilibrium constant. Okay, is the equilibrium constant. All right, and I am not going to dive too far into this because that is what your ed puzzle is on. Okay, so your ed puzzle goes in depth about what that K is. Okay, what I'm going to go through here is how we solve for that K. Okay, so equilibrium constant, there is something that you need to know, that it is temperature and pressure dependent. Okay, so our K for the equilibrium will depend on the temperature and pressure. Okay, when we calculate it, it will be at a set temperature. Okay. Ooh, I think I'm frozen. Is that good? Okay.
Mm-hmm.
All right. So, all right. Rate of reaction, you can go forward and backwards with RK. Okay. So when we're doing this, we are solving for the K constant. All right. But there are certain things. Okay. The reason that we need to solve for the K constant, it's going to tell us what direction is favorable. Okay, and after we solve for the first one, I'll go over how we know if it favors more reactants or it's going to favor more products. Okay. With that, all right, we're going to go through the first one, all right, and break it down. So our equation to set up to solve for K equilibrium, okay, all right, it is going to equal, okay, the concentration of a product to a power, the concentration of your other product to that power, okay, the concentration of your reactant, and the concentration of your other reactant. So we're going to write that down and then we're going to break it down because it seems like a really scary equation. It's really not. Okay. So those are your products. Reactants. Okay. Remember, if anything doesn't make sense, please just pop into the chat and let me know, okay? To find the power that you'll put your concentration to, okay? So to find any of these values, ooh, that's not what I want. Okay? It's just the coefficient from the balanced equation for that substance. Okay? So for example, okay, if we look at the first problem, all right, there are no coefficients in front to balance them, okay? Each of these are just to the first power. So you don't have to square it, you don't have to cube it, you don't have to do anything with it. Okay, and guys, we're gonna go through a couple examples, so don't stress if some of this isn't making sense, okay? The concentrations are generally given to you, okay? All right, but they do need to be in molarity because it's a concentration, all right? Okay. And the last thing that we need to know about this equation, okay? Solids and liquids are never included in this equation, okay? Because their concentrations are not going to vary in an equilibrium equation, okay? So we look at gases and aqueous solutions. Most of the time you will be looking at gases for this, okay? So what I mean by that, we're going to see here in problem number 1, okay? Okay. So if we look at problem number 1, all right, I'm trying to solve for my equilibrium constant. So I'm trying to solve for my K EQ value. Okay. I need to include the concentrations of anything that is not in a liquid or a solid form in my equation above. Okay. So we're trying to solve for K EQ. All right. My product concentrations would go on top. My reactant concentrations go on bottom. Probably helps if I spell reactant right. Okay. So if I look at this problem, all right, I would look at my product concentration. Okay. My product is sulfuric acid. Okay. But if you notice, okay, so yes, I do give you the concentration for sulfuric acid. But if you notice, it is a liquid, meaning that I do not include its concentration in the equation. Okay? So because there are no other products, we simply put a 1. Okay? Do we see why? It's because it's a liquid. Tima.
Wait,
Tima?
so on the part that says do not include ester, is that an E or an L?
That's an L. That's a cursive
Oh,
L,
okay.
sorry. Okay. So then our reactants do need to be included on the bottom because they are gases. Okay? So the nice thing for us, it's already in molarity. So we would write the concentration of our SO3, our sulfur trioxide, which is 0.400. There is no coefficient, so we do not need to put it to a power. So technically it's to the power of 1. Oop, that's not what I wanted. Okay, then our second reactant is water. It is a gas, so it is included. Okay, so it's 0.48. Okay, it is also has a coefficient of 1, so it's to the first power, which just means that it is as is. Okay, so now we get to just go ahead and solve. Okay, so for this one, all right, we have all our parts filled in. Our product is a liquid, does not get included. We have all of our reactants. We simply now plug in to solve for our equilibrium constant, okay? So you do 1 divided by 0.4 times put your answers in the chat and we'll see if we're correct. Anybody agree with Eden? Okay, Stephanie agrees. Katie agrees. I need 2 more. Yitzel says yes. 1 more. Oh, I get thumbs up. Oh, gosh, this internet thing is so cool. Okay, so awesome job, guys. It is, okay, it should be 5.21. Okay, and there are 3 sig figs. Okay, so the crazy thing about, thank you, Marco. Okay, the crazy thing about your equilibrium constant, and the thing that personally drives me insane about equilibrium constants, there are no units because they all technically cancel out. Okay, so whenever you write your equilibrium constant, all you have to worry about is sig figs. So that's your answer. Okay, so that means at equilibrium, our constant for this equation is 5.21. Okay, so now we need to know why in the world is Miss Edge making us solve for this equilibrium constant. Okay, equilibrium constants tell us certain things. Okay, whether it's going to favor the reactants, okay, where it's going to favor the reactants or it's going to favor the products. It tells us which direction the equilibrium equation favors, okay? Because remember, in equilibrium, it is a reversible reaction. Your reactants can make products, your products can make reactants, okay? So for an equilibrium constant, okay? So if your equilibrium constant is less than 1, okay, it is going to favor your reactants. Okay, so it's going to favor that direction. Okay, if your equilibrium constant is greater than 1, okay, it's going to favor your products. So if we look at the equation we just solved, are our reactants or our products favored? Oh, sorry, Katie. Okay, so again, that tells us if it's going to favor our reactants or our products, okay? Our K has to be bigger than 1 for it to favor our products. So as I'm seeing you guys answer right now, you are 100% correct, okay? It's going to favor our products because it is greater than 1, okay? Which means that it's going to generally be producing our products, okay? Do I have any questions with how we solved that one as of right now? Okay, so we're gonna do number 2, all right? So number 2, okay, has a couple things that we need to make sure that we're aware of, okay? So first things first, all right? We're at a set temperature, which is good because it means we can solve for the specific equilibrium constant at that temperature, okay? Then it says at equilibrium at 100 degrees Celsius, a 2-liter flask contains 0.075 moles of PCl of phosphorus trichloride, 0.05 moles of water, 0.75 moles of hydrochloric acid, 0.5 moles of POCl3, okay? And our job is to calculate the equilibrium constant, okay? We talked about this before, okay? In order to complete the equilibrium constant equation, we need concentrations. Moles are not concentrations, okay? Molarity is concentrations, okay? So does anybody remember the equation to solve for molarity? Yeah. Caesar, what's our equation?
It would be moles over volume.
Moles over volume. Eden also had it correct. So did Gio. You're close. Marco, you gave me the slope equation or the line equation. Close class. You're almost in the right class. Okay, so we're gonna do moles over liters. Okay, oops. All right. So the first thing that we have to do for all of these, okay, we have to get them into concentrations because otherwise we cannot use them in our equation, okay? So what I'm going to simply do, okay, is I'm going to take all of our moles and divide them by 2 because that's our liters for this equation. So I'm going to take every mole value and divide it by 2 because that's our liters for this equation, okay? So once you have solved, please put it in the group chat. Something I never thought I'd say in a classroom. Okay, so once you've solved, put your answers in the group chat. Goodness, golly gee, what kind of world are we in? All right, you can solve for any of them. All right, so Stephanie has our first one. Ooh, my internet tells me it's angry. All right, so we have our PCl3 value, and I agree with you, Stephanie. Ooh. Fatima has our value for water. Awesome. And then Astanet has our value for HCl. Awesome job, guys. These are looking wonderful. Just need our last value. And Fatima coming in clutch again with our value for our POCl3. Oh, and so is Astanet. Look at you guys just crushing this. Okay, so now that we have all of our concentrations, okay, we can go ahead and set up our equation to solve for our equilibrium constant, okay? So again, we have to see what are we going to actually include in this equation, all right? So there is one concentration that we should not include, okay? And that is gonna be our concentration for our PCl3, because why?
It's a solid.
Awesome job, Gio. It is a solid, so we don't need to include it. Same thing would happen if it was a liquid, okay? But we do need to include the rest of the concentrations, okay? So to set up my equation, right, I put the concentrations of my products on top, okay? So if you notice though, our HCl now has a coefficient, okay? So what that means for our HCl value, okay, we take our molarity, so we take our 0.375, okay, and now it has to be put to the value of the coefficient, okay? So in this case, our coefficient is 2, which means that this needs to be squared. So that's a great question, Eden. Eden asked, does it have to be in brackets or can we put parentheses? Brackets represent concentration. So for this, you actually do need to put brackets because the brackets show that it is a concentration. That's a great question. So yeah, I am gonna be a little picky with that because if you do this in college, they will expect it in brackets. Okay, then we need to put our concentration for our POCl3, all right? It is 0.25, okay? The coefficient that it technically has is a 1. Okay, then we are gonna go ahead, put only the concentration for our water below, because again, we do not include that concentration of our phosphorus trichloride because it won't have effect on the equilibrium because it's gonna have a fixed concentration throughout, okay? So now we are all set up to solve, all right? So go ahead and solve, plug it in, put your answers in the group chat. I am looking for 5 people, okay, to either back up someone's answer or put their own answers in. Sorry, everything's very loud right now. Stephanie has put up the first answer. So we can either agree with her or you can put in your own answer if you don't agree. Okay, I got Gigi's agreed, Manny's agreed. I need 3 more people. Caesar's agreed and Abe's agreed. So it's Allison. Wonderful job, guys. It is, okay. So we are gonna go off sig fig, so it should be 1.4. Okay. Katie also has agreed. Okay. How do we feel about this so far? Any like very like, I don't understand how to do this or anything like that? Why is it only 1.4? Because there's only 2 sig figs. We go based off the sig figs for your concentrations. 2. We're not gonna ever go off the sig figs for your temperature because we're only using the ones that you're gonna actually plug in the equation for. So go off the, oh, sorry. There's only 2 sig figs in the concentration, so that's why it's 1.4. We are going to do one last one together, and the reason why, okay, so if you go ahead and look at, is the one I want? Yes, okay. We are going to do number 3 together, and the reason why is because it is a different type of reaction, okay? So before, when we were doing these, we were solving for K, all right? If you look at number 3, your constant is given, okay? So we can use this type of reaction to solve this type of equation, my apologies, to solve for the equilibrium constant, or we can use the equilibrium constant to solve for an substance's concentration at equilibrium at that set temperature, okay? So for this one, it says KEQ is equal to 798 at 250 degrees Celsius. Again, we have to be at a set temperature and technically a set pressure, but we are leaving pressure out for right now, okay? For the reaction of sulfur dioxide and oxygen to make sulfur trioxide, okay? In this particular mixture at equilibrium, okay, and we have our concentrations for sulfur dioxide and sulfur trioxide, and they're already in molarity. Woo! We don't have to convert. Okay, and our job is to calculate at equilibrium the concentration of O2. Okay, and again, that brackets lets me know that I'm trying to find concentration. Okay, so this is where a little algebra comes in. Okay, promise you're gonna do great. All right, so we go ahead and we set up our value. Okay, so 798 is equal to, okay, remember the concentration of our products divided by the concentration of our reactants, okay? So our product in this reaction has a coefficient of 2, which means it's going to be to the power of 2, okay? So our concentration for sulfur trioxide is 11 cubed. That's kind of hard to see that 11, sorry. I don't know if that made it better. Okay. Over the concentrations of our reactants, okay? So we take the concentration of our SO2, our sulfur dioxide, which is also to the second power, okay, times our concentration of our O2, which is what we're trying to find, to the power of 1, okay? There will be cases where the concentration that you're trying to find is squared or cubed or to the 4th power, okay? All right. You can also, if it makes it easier for you, which is how I personally like to solve it, I put my value that I'm trying to find as an x. Just because then it looks just like an algebra equation to me, and I know how to solve those. So, do we want to go through how to solve this together, or are we comfortable enough to try to solve this on our own? Together? Okay. So, what we do for this, all right, we need to get x by itself, okay? So in order to get x by itself, okay, it is on the bottom, all right? I need to get it on the other side, okay? Because I need to be able to get it by itself, all right? So currently our 11 squared, okay, is divided by 4.2 squared x, okay? So personally, what you can do this two ways. You can keep your squared value together, or you can go ahead and get rid of the squared value and figure out what your x is. So that's going to be my first move. That's how I personally choose to solve it. Okay, so I know that 11 squared, okay, is going to be 121 on top. 4.2 squared, okay, is 17.64x. Okay. So order of operations, you do need to square before you do anything else. Okay. All right. Now I need to get that x value, all right, to no longer be divided by. So I'm going to take both sides and multiply it by our 1646x. 16.64x. Whoa, 17. Wow, I cannot, apparently can't numbers today. Any questions with this so far? I don't know whose paper that is. Eden, that looks good so far. No, no questions. Okay. So I go ahead and I take this, all right? So we have 17.64 times 798, which get a really big number. Okay. Then my final move, okay, has to be to get x by itself. So you're going to take both sides and divide it by 14,076. And in the chat, tell me what you got for your X, your concentration of oxygen. Stephanie is the first one to post something. All right, again, I need 5 people to either agree with her or disagree with her if you got a different answer. I got a yup, a positive, a yes, a yeah. I very like your variations in. Where do we get the sig from? That is a great question, Marco, okay? So we're always gonna take our sig figs from our concentrations, okay? So I know you asked me that on your own, but I'm guessing you're not the only person who has that question, because I get that question a lot, okay? Again, from our sig figs, okay? So if we look up at the top, all right? Non-zeros always count. Non-zeros always count. This 0 is after this answer is after, sorry, let me rephrase that. This 0 has a decimal point and has non-zeros before it, so it does count. So we need a total of 3 sig figs, okay? So if we look at Stephanie's answer of 0.00859, okay? There are sig figs. We have 3. Awesome. Okay. And in this problem, there is a unit because we're solving for concentration, which means it should be in moles. Okay. So your assignment for today, okay? You just have to try 1 problem on your own, okay? Because I've already taken up a lot of your time today, so we're not doing a crazy amount more, okay? You're not doing the rest of the worksheet, okay? I just want you to solve for 1 of the problems below on your own, okay? So there is 4 through 8, okay? You just have to pick 1 and solve for it, okay? Then submit it to me. Show me a picture via email. Okay? Any questions with that? So you're not doing the whole worksheet. Please don't do the whole worksheet. I've already taken up 45 minutes of your day. Okay? I don't want you to do that. Okay? 1 other problem. You can pick which one you want. Okay? Oh yeah, sorry, Alexis. Okay? And solve it and then send me a picture in the email. Okay? And that's it. Then you're done with chemistry for the day. Ooh, I know you're all so excited. All right. So tomorrow you have the Ed puzzle. That's it. Okay. So I'm gonna unmute you guys in case we have any other questions, comments, or concerns. Otherwise, you are free from Miss Edge. This one. Any other last minute questions?
No, ma'am.
No. I hope you all are doing well. Thank you for attending the meeting. I appreciate it. Hopefully.
Hi.
Miss you.
Of course, Miss Edge. I wouldn't miss it.
Bye, guys. Let me know if you need anything.
Bye.
Adios.
It's snowing a lot.
That's all.
Hasta la semana que viene.
A lot of snow. Bye.
Bye, guys.
Miss Edge.
Yes.
I said